All right, welcome to the part 3 review of the mastery. I'm thinking that we probably won't get to the entire mastery today during class, so I'm going to post this video to help out Math 7 with our Chapter 4. We called it the Chapter 4 Holiday Cheer Celebration of Learning. So we did page 1 together in class. Here's a quick overview of that. If you were absent, remember you're going to have work with these things. So if you're thinking just copy down answers, that's not going to work. Also, there is going to be a follow-up. So if any of this doesn't make sense, right, you want to talk to me because we have a follow-up assignment coming. We're reviewing page 2 in class today. So we see that Mr. Combs would use 29 gallons to go on that trip. Mrs. Pettigrew can make 16 cupcakes in an hour. Brad could deliver 120 newspapers in 2 hours. And so on. These answers we're going to review in class. 9 is probably 9 and 10 are probably the toughest problems, more so 10 than 9. 10 changes units, just like 9 does, but 10 tripped up more people than 9 did, and we'll talk about that in class. I don't really want to dive into it right now because you guys are going to start showing up in about 10 minutes. So let's look at page 3. So on page 3 it says the scale of a building shows that every 1 inch equals 8 feet. So when I sit down and work with you guys, pretty much all of you can tell me that if we do 2 inches, it'll be 16 feet. If we do 3 inches, it'll be 24 feet. But the thing we got to get more comfortable with is setting up these proportions. So you can see I've got it done here, but I'm going to do it again for you guys. So we take, and actually I'll flip this over. So we take our one value, such as 8 feet, and put it over our other value, like 1 inch. Now we can put 1 inch on top and 8 feet on bottom. It does not matter. What matters is that when we build the proportion, that our units agree. Our feet are going to want to go on top, and our inches are going to want to go on bottom. So 3 3/4, if you love decimals, you might convert that to 3.75, but we normally don't do that when working with inches. What we can figure out here is that to go from 1 inch to 3 3/4 inches, we remember that we have to multiply or divide, right? Proportions only work with multiplication and division because they're the same thing, right? So we can multiply here by 3.75. We'll do the same on top. Now this is when we don't have to pull out a calculator, guys. We can do 8 times 3. I know you can do that. And then 8 times 3/4. I know you can do this also. Just a lot of times you don't really want to put in the work. This would be 24 over 4, which would be another 6, right? What is 3/4 of 8? Oh yeah, if we break 8 up into fourths, that makes sense. So 24 plus 6 gets us 30 feet for that. What the actual distance would be. It would be 30 feet when it was 3 3/4 on the drawing. For the difference between x squared and 2x, most of us were pretty good at this. I don't know if I have an x squared in here. But like we talked about in class, guys, these are 1x tiles, and they do have area. I want to make sure that we're not confused on that. 1x tiles have area. They just only have an area of x because they're 1 on this end and x on their long side. So it's x times 1, so the area of this is x, versus x squared, which has a length of x on both sides, and its area is x squared. So let's say x is 5. The area of one of our x tiles is going to just be 5 because it's 5 times 1. But the area of an x squared tile is going to be 25, right? Because it's going to be 5 by 5, which makes it have the area of 25. So writing something like that for explaining the difference between x squared and 2x would be perfect. Down here, I've already helped a few of you on this, but area and perimeter, we did a lot of this in class. I'm again going to do it again in my green pen and break it down slightly differently. So this length on the x tile, right, from here to here is x. This length on the x tile is also x, which is how we get our 2x on top. Same thing on bottom. We've got x and x, making that 2x. The ends of our x tiles, we said, they are 1 by x, right? So this length right here is a 1, and so is each of them, making that together 4 on this side. Same thing if we go on to the other end. Just make your life easy and go ahead and do the side you know before you tackle anything else. Then our 1 tiles here, right? We said the baby square tiles, these are what we're calling 1 tiles, so they're 1 by 1, which means we have 1, 2, 3 across this section, and 1, 2, 3 across that section. When we add up our like terms, we get 4x plus 14. Now perimeter is what most of us have been doing like all right on unless we accidentally involve the x squareds, but we'll talk about that down in the next problem. So remember, when we talk about area, it's just what's on the inside. So all these numbers on the outside, that's our perimeter, right? But on the inside, we have 1, 2, 3, 4 x's, 5, 6, 7, 8 x's in total, and then 3 by 4 for our one tile section, which gives us 12 for our one tiles. So we get 8x plus 12. All right, we're going to do 15, but I need some coffee. All right, so 15, what goofed some people up is there's kind of a trap door here with this side that I have highlighted in pink, which we talked about these things in class. If we're going to be missing a section, the way I kind of want you guys tackling this right now is to just go ahead and think about that section being missing, and that's what gives us this -1. I feel like in the years that I've been teaching this, this makes more sense to kids, because then in a separate thought, we can think about how here, here, and here makes our 3, right? So this pink edge, if it was all the way continuous, like over here, let's go ahead and mark that up. This edge over on the right-hand side, the edge of an x tile, is x long. And x squared, both edges, right, every edge, is x long. But when we put this tile up on the side, we don't get that length right there. Unless, and this is where it's dangerous for me to explain both things, unless you imagine this line scooching down and being part of that, and then you'd only have a +2 over here. But that's why I don't necessarily want you guys to think like that. That's a little bit more complicated right now. Easier to say that this pink section is x minus 1. This blue bump out gives us an extra 3. And again, I'm talking about perimeter first. I like to tackle perimeter first. I don't know why. Probably because I already wrote stuff on my paper. So then this section up here is a bonus 1. These over here are 2 more 1s, making that 2. Our section across the bottom is a 1 because the short edge of our x tile is 1. So when we add all those up, combining like terms, our perimeter becomes 4x plus 6. We never use x squared in perimeter. X squared is referencing the space taken up inside of this tile. Right, so our x squared is only ever going to be talked about during area. So let's talk about area. This tile right here gives us the x squared, right? This tile right here, we already talked about in the problem up above, that gives us our 1. And then these tiles, we've all agreed, are just x tiles because they're x by 1, and that gives us our 2x. So our area there becomes x squared plus 2x plus 1. If you did not write about yourself on the original test, I do want to see that. I took notes on this stuff. I was interested to see what you guys do over the holidays, so I do actually want you guys to do that. So write about yourself if you haven't, and turn that in with your revision. Remember, guys, revisions are on a separate piece of graph paper, but because I forgot to remind you of that at the beginning of the video, if you goofed up, just come see me. We can talk about it. Just as a little bonus content in here, let's go ahead and talk about 9 since I've got a couple minutes before you guys show up. So number 9, the thing that's really messing with people is I'm allowed to work inches to feet if I want to. So if I'm going to go ahead and say that the scale I'm working with utilizes that every 6 inches is equal to 42 feet, I can keep those labels different if I want to. So I'm going to go ahead and solve it that way first, but then I'm going to show you the other way. And this is why, this is my answer key, right? It says times 7 or times 84. There are 2 different answers that would be counted right here, and actually probably even more than that. So I often like to put my bigger number on top in these situations just to make it make a little bit more sense. And once I get this written down, I'll tell you why. So we're going to build a proportion, right? Pretty much everything we're doing this year deals with proportional relationships. Sorry, not feet. You goofed up already. Guys, this is why you don't do math in pen. And don't talk while you're doing math. Well, you talk with each other. Just be careful talking while you're writing down your math. So both of these actually work well together. 42 and 6 kind of get along because they can both be divided by 6. So if we divide both of these by 6, we're going to get 7 feet, and we're going to get 1 inch. So what that tells me is that my scale, what I could actually like write out and make to kind of say this more easily, is like the problem that we had up in, I don't know, we solved it in this video. Like problem 12, I can get this down to saying we have 7 feet per inch, right, just 1 inch, or we could say every 1 inch equals 7 feet. We can say our scale in either order, feet per inch or inch per foot, but this is not inch per foot, right? This is 1 inch equals 7 feet because our feet was the larger number. We did not get that down to a 1. So we can use this scale to solve the problem, and we're going to talk about solving it in class, but again, we set up another proportion. Excuse me. Or we now, if we want to, can say, well, 42 feet, I know I can turn that into inches. I'm going to draw a squiggly line. I'm actually going to fold my paper to make our life easier. If I want to turn 42 feet into inches, what do? That's right, multiply by 12. So guys, 42 times 12, I don't need the calculator, even though you just caught me looking for it. 42 times 12, I can do 42 times 10, and that gives me 420, plus another 42 times 2, which is another 84. So 504, and let's go ahead and verify that in our calculator to make sure that we're not making any mistakes. Yep, 504. And we've now converted to inches, right? Do not forget your label. So now if I say 6 inches is equal to 504 inches, we know that that's not actually like true because it's a scale. So this is saying 504 actual inches compared to 5 real, or sorry, this is our measured, our drawing, our scale, right? Because we're talking about a scaled model train. So 5 inches on the model would actually equal 504 inches in real life. So then, here's where it gets tricky. They do feet again. So the fact that I've converted into inches and inches, I can still set up that proportion of 5 inches on the model is equal to 504 inches in real life. But now, where do I put this feet when I go to try to solve it? I can't put it anywhere. If I'm using inches and inches, I don't have anywhere in the proportion to place that, so it makes more sense to use my proportion that involves the feet. So if I use that, my work is very much not organized how it should be. So you guys do your work better than me. 7 feet is on top. Doesn't matter if it's on top or bottom, but what matters is that I put my other value where the labels can agree. So feet on top, feet on top. I can now figure out how do I go from 7 feet to 182 feet. And if we don't know how to multiply forward, we divide backwards. We get 26 inches here. Now another thing we could have done is not simplified the scale, even though I kind of ask you to simplify the scale in part A. If we don't simplify the scale, you can still build a proportion using the 42 feet and the 6 inches, so I might as well keep rolling on this train. See what I did there. 42 feet over 6 inches. Feet to feet, so 182 feet would go on top. We don't know how many inches on bottom. We need to figure out how to multiply to get there. I can divide backwards if I would like. So 182 divided by 42, because I'm not that good at math. So 4.3 repeating. Yeah, there, my camera finally focused. I don't want to pull that number out of the calculator. I want to keep it in the calculator because it's a repeating number, or I should kind of change it into mixed number form. So just hit multiplication, grabs the previous answer. We hit times our 6 on bottom, which is what we're trying to do. And we get 26, which we can check what label should it have, inches. Because our denominator had the inches label. All right, you guys are starting to show up. I can hear you out in the family room. So I'm going to go hang out and say good morning to you. And hopefully this video helped you get these revisions done so that we can take our follow-up assessment next week. So hopefully you guys have a great weekend, and I'll see you on Monday.